Good morning, students. In this session, we are going to see what is operating system structure, the second part of the first unit. And in that, we are going to cover what are system calls and types of system calls. Myself, Dr. Shirisha, Associate Professor from CSC Department, MLR Institute of Technology. So here we are going to cover system calls. So what is a system call? Whenever you wanted to communicate between the user and the kernel, then you need to send some functions, and those functions you are sending with the help of these system calls. And what are its types? So these system calls are having different types. So we'll discuss what are the different types of system calls. Coming to different types of system calls, we have a process. We have to discuss these system calls with respect to 5 things. One is a process control, and in that process control, where these system calls are being used. So if you see in the process control, we have to create a process. If you wanted to create a process or if you wanted to terminate the process, then you need to use one system call. So that is how that helps the process to control. So this is one as a creation and the other is a termination. And for end or abort signals, if you wanted to send, you need to send a system call. Similarly, load and execute. You have created a process and this process has to be loaded from your physical memory to your main memory. So if you wanted to send this, then you have to load it. So for which again you need a system call. Then execute. So exec function is used as a system call for execution of a process. Similarly, this creation of a process also you have a system calls, and you have fork to create a process which is used in the Linux operating system. And operating the system to operating system, the system calls which we are going to use for creation of for the purpose of controlling the processes may vary. Okay, so that is create system call is used in the Windows operating system for creating a process, and in the same for the same create process, fork is used to create in the Linux operating system. So in such a way, this is one example where I am showing you how the system calls differ in both the operating system. Similarly, get process attributes, you have get methods. So those get methods we call as get system calls, which we are going to use to fetch any data. And similarly, set the process attributes. Set means where you are assigning some values. So wait for time, wait for event or signal event, any interrupt if you wanted to occur, any interrupt should occur, then you have to give this wait for time, wait event and all. Allocate and free memory. If you wanted to allocate the memory and if you wanted to free up the memory, then also few methods like alloc and clog, mlog, okay, clog, okay, like that. These are the few system calls that we have. And dump memory if error, this also where you need a system call. And debugging the bugs in a single step, and logs for managing the shared data, where a process communication IPC can happen remotely, where you need two things. One is a message passing and the other one is a shared memory. So for these two also you need the system calls. So if you use a system calls, we can do 1, 2, 3, 4, 5, 6. So we can do all these 10. Okay, with respect to the process. Similarly, we can move to the other criteria, which is a file management. A file can be managed. So where you can create the file, you can delete the file, you can open or close a file. So how do you create? Simply create function. Similarly, open function, open system call, close system call. So these are all what the system calls that you are going to use with respect to files. And previously, whatever the system calls we use, that is with respect to the process. Okay. And similarly, when you have a file management, the 3 things come into the picture: read, write, execute. These 3 are also very important. Read is to fetch the content or to retrieve the content and to use it. Okay. Write is where you are writing the data into the file. And reposition is also one of the attribute that you can, one of the system call that you can use. And get set in the process, will be replaced by get and set attributes with the files. Okay, these are the few operations that we can do. These are the 5 operations. And nextly, device management. So what is device management? Device is if you wanted to attach or detach some other USB ports or floppy disk or compact disk, anything. If you wanted to communicate with them, then we are trying to use these device management system calls. So request to the device, where you request some device and where you release the device after its use. So for which you need to send some communication to the kernel so that it understands the purpose or the process has completed its job. Then you can detach those devices from its use. So then we use those system calls. So what are those system calls? We'll be discussing in a minute. Then read, write, reposition. Similarly, how you have here read, write, reposition, the same with the device management, you can use this read, write and reposition, because device when it is attached, what you'll have? You will obviously have files. When you have files, you have to open, you have to read it, you have to write it, etc. like that. Get device attribute, set device attribute. These are the again set and get methods which are used to read or write or reposition or whatever. If you wanted to retrieve, you will use get method. If you wanted to set the values, then you have to use a set methods. So logically attach a device, detach the device. Okay, so these are the 3 areas. One is a process control, the other one is a file management, then is a device management. And moving further, we also have to use the system calls in these cases where information maintenance should be happening. Information maintenance. So get time or date, set time or date. So where information means you have the system where the system time should be synchronized like that. Get system data, set system data. Okay. And get and set process, files, device attributes, whatever. If you wanted to upgrade or if you wanted to maintain some information, then we are going to use such system calls. Okay, we are just discussing what are the purposes where system calls are taking a major role, where to use the system calls. Next will be the communication. Communication again is what I told you, inter-process communication, where inter is remotely communicating with in between the processors. Therefore, this process communication can happen in 2 ways. One is message passing and the second one is the shared memory. One is a message passing. Message passing is always 1-to-1. Okay, 1-to-1 means you say WhatsApp. If you are sending any message to a contact, a single contact, then that is a message passed to 1-to-1 communication. If you wanted to share, that is shared. So 1-to-many or many-to-many also can be possible. That is shared memory. Suppose if you have WhatsApp and you are sending the messages in groups, so that is one person is sending a message within the group which is shared among all the users who are in the group. That is a shared memory. So system calls will vary based upon the criteria where you are using, okay, based upon the requirement. So send and receive the messages through message passing model, okay, to host name or a process name. This is in the model of client server model. Next, shared memory model is again to gain access to memory regions, transfer status information, attach or detach remote devices. So this is all happen when you were talking about the communication. Okay, then finally protection. So process control, device management, okay, and file management, then information maintenance, then will be the inter-process communication, that is communication. Finally, protection. So once you achieve all the above, they have to be protected, then only your data will be resided. It will not get lost. So for that reason, we are using this protection. Control access by using a access control list. We also call it as access control list or access modifiers, where you give read, write, execute permissions. Okay, in the three different ways, either for the users, either for the group, either for the others. So these are the different groups where you have to control the access. Therefore, the read permissions can be customized and write permissions can be customized according to the user's requirement. Similarly, get and set permissions, allow and deny the user access. All are possible only with the help of the access control list. Get permission. Whenever you have some file, if you are not editing that or if you are not giving the permission for that, then write permission, then no one can write into it. It will be only opened read in the compatibility mode. There is one example where you again have to give the execute permission if it is a Linux operating system. So chmod is a command that is used to change the permissions. So if you give 777, then you are giving all permissions for users, others and group also. Suppose if you are giving only 6, that means you are stopping the execute permission. So like that, based on 444, you are giving only the read and write permissions or only read permissions. So like that, it varies how you wanted to access it or how you wanted to control the permissions that you wanted to give. That is possible with the help of this few methods or few system calls. Okay, in that way we can provide the protection. Then we have as an example for Windows and Unix operating system. We have taken 2 operating system for case study here. For the discussion, for differentiation. So we have discussed the process control, file manipulation, device manipulation, information maintenance, communication and protection. So these are the areas where we have to use the system calls for communication purpose. And these are create process. So create process is the system calls. These are the actual system calls that we are using in the Windows operating system. To create process, this is to exit the process, terminate process, wait for a single object, wait for time. This is wait for time. And similarly, when coming to file manipulation, we have create file system call for creation of the file. The same, if you see, this varies. Here you are using create file, here we are using open, because this is a Unix operating system. So from Unix to Windows, the system calls will vary. Similarly, read file is used to read the file, and here read system call is used simply. Write file, write system call. Wherever you are using files, just you are placing file in the system call as a postfix. Then close handle, just a close system call for terminating the file. Okay, and similarly, device manipulation, information maintenance, these are the different system calls that we are using. And chmod, as I told you, we can use for changing the modes. Okay, read, write, execute permissions. And this is umask for changing the mask, and this is for changing the owner of the particular file. This way how we are providing the protection in the Windows. Set file security and initialize security descriptor, set security group descriptor group. So this is also something we use. And in the inter-process communication, we have to use pipe, shared memory, get and message passing. This is mmap. And create pipe, create file mapping, map view of file. These are in the Windows operating system. Similarly, information maintenance, get PID, process ID, alarm sleep, and get current process ID, set timer sleep. This is to stop your process. So this is information maintenance. Similarly, input output control, IOCTL is a system call that we use in the Linux for input output controlling. Read permission read and write permission write. Here read console, write console. The same is changed in the information maintenance, which is again in the Windows operating system. So like this, we use several set of system calls. These are just a few system calls that I am showing you here. Apart from this, we have many system calls that are needed to be discussed, but based upon the requirement of the user, you need to understand which system call is to be used so that it fulfills the requirement. Okay. And if you see this example here, this is a standard C program where we are writing a small code, and this is in the user mode where he writes the code and it sends to the kernel. So when it is sending to the kernel, you use the write system call. Therefore, this will be understood by the kernel that something should be happen here, and it again returns that to printf, that is greetings, so output will be greetings. So how you are getting this as output? Because your kernel is understanding that it retrieved the write system call, so it has to write onto the output. What is that you are giving? Okay, what is that? It has been written in the code. So this is how it invokes the printf library call, which calls the write system call. So have you anywhere written write? No, but internally, who is calling this write system call? Your kernel. So whenever this printf is being called, internally kernel should understand that it should write something, so that it should call the write operation. Similarly, if you wanted to read scanf, okay, then it will call what? Rather than write, it will call the read system call. Again, operating system to operating system, it differs. So this is how system calls are very important, and they play a key role in the operating systems. Hope you all understood. Thank you all.